So now if we look at this question, they say to us, the graph of f of x, which is defined as x plus 4 times x minus 6, it's already factorized for us. And they say to us it is drawn below. Now, this parabola, which is f of x, it cuts the x-axis at point B and D. And it also cuts the y-axis at the point G. Now, furthermore, they say to us, C is the turning point of the function of f. And they say the line AE has an angle of inclination of theta. So now they're taking you back to analytical geometry, grade 11. The line AE has an angle of inclination of theta, and it cuts the x-axis and the y-axis at points A and E, respectively. And they say to us, T is a point on the function of f between B and G. So this is how the whole sketch actually looks like. It's a very nice function. And who said we can't ask you analytical geometry in functions? As long as you're doing mathematics, that's the most important thing. Right, so let's see what does the first question say. So they say to us, write down the coordinates of B and D. Don't calculate them, write them down. Well, the reason why they say write them down, it's because the function is already factorized. So what you're going to do here is to equate the whole function to 0, and then you solve for x, right? So let's go to the whiteboard and solve for x. Well, you don't really need to show those workings. You only need to show the coordinates, right? But then at the back of your mind, you understand that what happened is the fact that x plus 4x minus 6 was equated to 0. And using the zero factor law, you find that x is negative 4 or x is positive 6. But now, they don't want you to show this, right? So what the examiner is actually looking for is for you to tell him that if we look at point B, we can see that it's on the negative x-axis, which means quite simply, the x-coordinate has to be negative. And since B is the x-intercept, it means the y-coordinate has to be 0. And then D is on the positive x-axis, so it makes sense for us to say the coordinates of the point B are exactly as you see them. So this is all the marker needed you to write. Don't show your workings. Write down. So if we look at the next question, it is asking for the coordinates of C. And if you look at C, it is the turning point of the function of f. And that's what they told you in the statement. So we actually have two ways, in fact, three ways of finding the coordinates of the turning point of a parabola. When you're doing grade 11, you learned two ways. And now in grade 12, we added another way. So you used to use the equation of x equals negative b over 2a, or you completed the square. But now here you understand you can also differentiate your function. So let's go ahead and find the coordinates of the point C. So remember that our function is given to us in vectored form. It's x plus 4x minus 6. But we can't find the coordinates of the turning point as long as it is in vectored form. So we need to expand this function. Of course, we are going to expand by using the FOIL method. So we say x multiplied by x multiplied by negative 6, 4 multiplied by x, and 4 times negative 6. So when we do, we get x squared minus 6x plus 4x minus 24. And then collecting our like terms, we see that the function will be x squared minus 2x minus 24. So if you still want to stick to grade 11, you can say in order for you to get the x coordinate of the turning point, you're going to use this formula and say b is going to be negative 2 and your a, it's just going to be 1. So negative by negative is a positive, and 2 divided by 2 is just going to be 1. So it means the x coordinate of the turning point is going to be at 1. So now that you know the x coordinate of the turning point, the next thing you must do is to find the y coordinate. How do you find the y coordinate? When you substitute this value of x into the function itself. So in other words, you find the y value when x is 1. So you can substitute it here or on the expanded version. Well, it's up to you. But let's take it to this one. So you'll just say, well, I'm going to have 1 plus 4, which is 5, and 1 minus 6, it's negative 5. So it means the y value is just going to be negative 25. So what? So now you can conclude and say, therefore, the coordinates of the point C will be 1 and negative 25. Remember, that's if you chose to stick with grade 11, then you're going to follow exactly this approach. But if you are doing life science and you learned about Charles Darwin as well as natural selection, then you understand that you want to adapt to change. So now how do you adapt to this change? Well, you want to use grade 12 in order to find the coordinates of the turning point. How do you use grade 12? Well, derivatives, calculus, right? So you understand something that is terribly important. The fact that at the turning point, the derivative of a function is equal to 0. So that is the principle you're going to use in order to find the coordinates of the point C. So let's go ahead and use that principle. So you're going to differentiate your function. And this is the function you must differentiate, the one that is expanded. Remember that according to the rules of differentiation, you cannot differentiate if you have brackets. You need to destroy the brackets first, which is what we did, right? So now you'll come and say derivative of 2x, in fact, x squared, sorry. It's going to be 2x, and derivative of 2x is negative 2. Negative 24 is just a constant, and the derivative of a constant is 0. And then you equate your derivative to 0, and then you solve for x, right? Then you'll find that x is going to be 1 once again. And then once again, you'll substitute the value of x into the original function, either here there, or there. So it's really up to you where you choose to substitute it. But if you set this, they're going to be so happy in the exam that they give you your full 2 marks. And then if we go to 7.3, they're saying to us, please write down the range of the function of f. And in order for you to state the range, it's only 1 mark. So you need to remember what is your range. It's where the function begins in terms of y values and where it ends, right? It's just the values of y for which the function is defined. And in the case of a parabola, which is facing upwards, it's going to begin at the turning point in terms of y values, and it's going to end all the way at positive infinity. Do you see that? So then, since we know it begins at the turning point and it ends all the way at infinity, then this is how we are going to state the range. And you can state the range in one of two ways, putting in mind that the y-coordinate of the turning point is negative 25. So this is what you can say. You can say the range is all the values of y. So you can say y is an element of values from negative 25 all the way to positive infinity. So we don't include infinity because infinity is not a specific number. But here we include negative 25 because the function starts at exactly negative 25. But if you don't want to use the interval notation, you can use the inequality notation and say, well, the range is any value of y which is greater or equal to negative 25. So that's the range of your function. So now let's look at 7.4, which is one of the most interesting questions in this case, of course. So here they say it is given that theta is 14.04 degrees and the tangent to F at point T is perpendicular to the line AE. Listen to what they say. They say to us, if you draw a tangent at the point T, it's going to be perpendicular to the line AE. And remember that theta is the angle of inclination of the line AE. So now, given what you are given, they say to you, calculate the gradient of the line AE, correct to 2 decimal places. Now the question is, how are you going to do that? Well, you're going to use the angle that you are given. They're asking you to please quickly run and go back to grade 11 and then come back so that you finish the exam in time. Imagine. So this is what you learned in grade 11. You learned that The tangent of theta is actually equal to the gradient of a straight line. That is how we defined the inclination of a line. So in other words, the gradient of the line AE is just going to be the tangent of 14.04 degrees. So if you press this into your nice calculator, you're going to get 0.25 because they said, please write it to two decimal places because after this you have zeros, so they don't contribute anything to this 5. But remember that 0.25 as a fraction, it's just 1/4. Right. Now, what does the next question say then? Now that we know the gradient of the line AE, so let's look at it. Well, they say to us, please calculate the coordinates of the point T. And this is for 5 months. Now the question is, how are you going to find the coordinates of T? Well, you're going to use the fact that the tangent line that touches the function of f at the point T is going to be perpendicular to the line AE. I think we need to illustrate it on a diagram, né? Even if it's not a beautiful diagram, just a rough sketch. So this is our nice Cartesian plane, which is very nice and beautiful. And here we have the function of f, which is doing something like this roughly. And then here we are going to have the point T. But before we have the point T, we have a straight line, which we call AE. So this is how AE is actually, I don't know it's actually what, but yeah. So here we are going to have a tangent, and we know that a tangent touches the curve at one point only. Of course, this sketch is not neatly drawn. It's just a rough sketch, right? But this is the most important thing they say. They say to us the tangent is going to be perpendicular to the line AE. So now we want to find the coordinates of the point T. So this is how you're going to approach it, right? How do you approach it? Well, it's easy. Remember, we know the gradient of the line AE, so we can use that fact in order to find the gradient of a tangent. How? Well, in analytical geometry back in grade 11, they taught us that if you multiply the gradients of two lines, the answer will be -1. That is what they said to us. So in other words, if you take the gradient of a tangent and multiply it by the gradient of the line AE, you're supposed to get -1. So we are looking for the gradient of a tangent, but the gradient of the line AE is 0.25, and the answer must be equal to -1. So dividing both sides by 1/4, and -1 divided by 1/4, it's just going to be a solid -4. So now we know the gradient of the tangent. But then you need to remember something that is terribly important. What is the gradient of a tangent? I want you to remember that in calculus, you used to give these many names. One of the names you said it's the derivative of a function. That's the first name. And the second name you said it's the gradient or it's the slope of the tangent line to the curve at any point. Remember what you said. So in other words, where you see the gradient of a tangent, you actually see the derivative of a function. So what am I saying to you in simple language? Now that you know that the gradient of a tangent is the derivative of a function, then it means you need to differentiate the function of f. And you already did that. You said the derivative is 2x minus 2. But now we have something that is very important. We said the derivative of a function is actually the slope or the gradient of the tangent. So we are simply going to equate the gradient of a tangent to the derivative of a function. So trying to solve for x, well, we take this negative 2 to the left, it becomes positive. So negative 4 plus 2 is 2. So it means the value of x has to be negative 1. So what is this negative 1? Well, it's just the x coordinate of the point P. So in order for you to find the y coordinate, you're going to substitute negative 1 into the original function. So this is what you will say. And then you say negative 1 plus 4 is 3. And then negative 1 minus 6, it's negative 7. And 3 times negative 7, it's negative 21. So what? So now you can conclude and say the coordinates of the point T will be negative 1 and negative 21.